Hello all, it's a pleasure to present this project. It is a little bit a fun history, and sometimes also a medical product can be developed by a fun history, because it was Julien Perret from the company Venesis, and his grandmother asked him during the crisis, can we not make a mask out of fabrics, normal fabrics? And then the idea was, if we use fabric, so there is already, it was this big shortage that no one had the masks, the disposable masks. And also, we could strongly reduce, if we have a mask which have the same filtration, we can strongly reduce also the impact, the environmental impact to throw away the mask. So this was the reason Jean-Luc came to us, Coatix. He came to Philip Morris to know if there are some filter material which can be reusable. To Coatix, if we can coat this, that it's washable and so on. And we created this consortium together also with the University of Bern and the CITEM Inselspital in Bern, CSEM, Epitelix, and all these companies. I let now make the next step to Adrian.
Thank you. So as a first step in this project, when you have something so massive, so ununderstood, first you need to build a database. So we build a database of materials. Really, we used an AI that informed us what kind of materials people used across the world as COVID was unfolding. And we selected those first, but we weren't limited to those. Everyone chipped in. We partnered with a fashion industry, and we got more material. So we built a comprehensive dictionary of these materials, informing us. And what you see here on my left is what is their filtration efficiency? What is how well do they filter the particles we emit? This was around 300 fabrics. And for this, we repurposed capabilities from all the members of the consortium. We looked at aerosol filtration, pressure drop measurements. This will inform you about the breathability of a certain fabric. It will inform you how comfortable the mask will be. And the aerosol filtration will inform you about, okay, how much aerosol passes through the respective material or through an assembly of materials. We also developed the testing material folding, because the mask, we all know, is going to fold, is going to go in the pocket. So we did all this research within a few months. And in the end, what we found is that no one fabric will cut it. No one fabric will be good enough to actually make a mask out of it, and for that mask to be efficient. So then we went to assemblies. We went to layering of these fabrics, and in the end, we settled with a front layer, which is made of 80% recycled plastic bottles, a filter on which Coatix applied a hydrophobic coating for enhanced performance, and cotton absorbent layer that is close to your face on your mouth. Now, applying a hydrophobic coating on the filter, you might wonder, okay, what will that do to the filtration and breathability? And the answer is, well, nothing. Actually, if it does anything, it enhances the filtration capability of the filter with somewhere around, what is it, 6 to 7% maximum, around 1 micrometer. So if anything, applying a hydrophobic coating to the filter will be beneficial for this mask. And with all this effort, with these thousands of hours that went into research, what we did, we conceived a product, a mask that is washable 40 times, and a filter with the coating is washable 100 times at least. The mask can be ironed at 120 degrees. All the components of the mask have been tested and certified for contact with the skin, so there is no problem. They can be on your face. The filter is coated, as I said, with a hydrophobic layer to preserve breathability and filtration, and of course, it's fast drying. All this has been scientifically substantiated in a paper which is now published in a scientific paper, which is now published. But I let Andreas talk about the hydrophobic coating. Thank you.
Exactly. So why coatings is because we have the technology depositing by PVCVD. It's meaning we can apply a thin film by gas phase. And this is the advantage because the gas goes into the filter and can coat everywhere without closing the filter. And we have still the breathability. Compared to a liquid coating, if you complete closing the filter and then you cannot breathe through. So we have developed this first biocompatible parylene and ceramic coating, and we used one of this ceramic coating to make this hydrophobic coating. And the advantage also of the ceramic is that it's resistant against washing, because you have to imagine if you wash this filter, these are high, strong mechanical impact on the fabrics. So what it have to be, the coating? Of course, it have to be a high contact angle that the water cannot go inside, and if water goes in the filter, we will lose the breathability and also the filtration somewhere. And this was measured with the contact angle, where you can see here, image A is a high contact angle, and image B a low contact angle. Then the coating is really thin, also not to close the pore of the filter. It has to be penetrate everywhere, because if we have some fibers which are not coated, the water can still diffuse into this fiber. Remain active and also support the washing, and we have to apply it to different fabrics. So we get a lot of fabrics from different companies, and we tried also over 500 deposition to find the good combination between the fabric and the coating, because not all fabrics can be coated, and it works only on specific fabrics. And finally, as you can see here, below you see in this where the droplet is still on top of it, and on the other side, if it's not coated, the fabric takes directly the water up. And then it's really hard to breathe through. So here you can see with the coating, can see here this is toilet paper, which we coated, and the coating or the water goes not inside, and it's completely hydrophobic. So on the fabrics, we achieve a contact angle between 120 to 140, which is really a good value.
And with all this, we design a mask, a reusable face mask with enhanced functionality. What we found during this research is that the quality of the nose pin, that matters a lot in filtration. The adjustable elastic straps allow you to actually fit it on your face, and the hydrophobic coating maintains its performance for a very long time, actually hours, without the filter getting damp, without loss of functional. The prototype has been tested all around the world, and in August it has been developed internally in Japan. And with this, I leave you. I have to thank all the participants, including Andreas from Coatix, and all the participants in this study, and you for your attention. Thank you.
Thank you.